All right, here we go. Unit 3, Lesson 2, the chain rule. Students will be able to apply the chain rule to find the derivative of a function. So we're going to start off by considering the function f of x equals 2x plus 3 cubed. Now, this is a function that we could find without the chain rule, and we would only be able to do that if it was in standard form. And what I mean by that is we would need to expand this out. So we would need to go ahead and we would need to find the expansion of this function as 2x plus 3 times 2x plus 3 times 2x plus 3. We would need to actually work all of this out. So we would need to convert this to 4x squared plus 12x plus 9. And then we would need to multiply that by 2x plus 3. It's going to get ugly pretty quickly, but what we'd have here is 8x cubed plus 12x squared plus 24x squared plus 36x plus 18x plus 27, 8x cubed plus 36x squared plus 54x plus 27. And so this is all equal to f of x, and so f prime of x, using the power rule, would be 24x cubed plus 72x plus 54. So tedious but not impossible. Tedious but not impossible. Now, one thing that you might be tempted to do is be tempted to say, oh, f of x is 2x plus 3 cubed. Well, I know the power rule says that f prime of x would have to be 3 times 2x plus 3 squared. Turns out, if you do that out, that is not correct. This is the tempting but wrong version. Here is the correct way, and what we're going to call the chain rule. And so this would be a way to find derivatives here, even if that was like a to the 5th power or something that got even crazier. And so the chain rule is what we're going to use for differentiating composite functions. Remember, a composite function is a function inside of a function. So if we look at our original example, 2x plus 3, that's a function that is inside x cubed. You can imagine this like x cubed, and we plugged in 2x plus 3 to it. So that's what a composite function is. And the chain rule says if you have f of x, where f of x is equal to, I'm going to read this out carefully, g of h of x. Whenever you read one of these things and there's two ofs, that's how you know you've got a composite function. So if you've got g of h of x, the derivative, it turns out, is g prime of h of x times the derivative of h of x. G prime of h of x times the derivative of h of x. Now that's one of the more confusing ones until we just break this out simply. What we have here is we are always going to define an outer function and an inner function. The inner function is what's getting plugged into the other one. So in this case, the inner function is 2x plus 3. Your outer function is this cubed. So I'm going to call it just x cubed. Your outer function is your g of x. Your inner function is your h of x. And so if we wanted to find, right, if we wanted to find first, what is g prime? Well, g prime, we can just use the power rule. That's the derivative of x cubed, which is 3x squared. Now, what the chain rule says is it's g prime of h of x. That means stick h of x, which is 2x plus 3, into g prime. So the first thing we're going to have here is f prime of x equals 3. I'm going to leave an empty space here, squared. That's this 3x squared. But I'm going to take that x and I'm going to replace it with my inner function, 2x plus 3. Then we are going to see we have g prime, which is 3x squared, but instead of x, I plugged in the inner function. Now we are going to multiply it by h prime. H prime is just 2. So this is all going to be times 2. And so what we have here as a final answer is 6 times 2x plus 3 squared. This is 6 times 4x squared plus 12x plus 9. This is 24x cubed plus 72x plus 54. And so you can see that this is going to save us a good amount of time and get us the same answer. Now, just like before, there are cases such as when you are using your trig functions where you just have to use the chain rule. So let's see what that looks like. We're just going to do one more example of this first. If we have f of x is equal to the square root of 2x plus 5, almost every time when I see this, I'm going to rewrite it as 2x plus 5 to the 1/2 power. Now I'm going to do this the quick way, right? And then we're going to go back and unravel it, because I want you to see what you're going to do in a while is you're going to realize, oh, this is how the chain rule works. My outer function is x to the 1/2, right? So I pretend x to the 1/2. Well, that would be when I take the derivative, of x to the 1/2, I would have 1/2 x, I'm going to leave a blank parenthesis there, to the negative 1/2. Then I'm going to stick in my inner function, my 2x plus 5, times the derivative of that inner function, which is 2. But really what's going on here is your outer function, your g of x is x to the 1/2, your inner function is 2x plus 5. But over time, you're just going to get faster and faster at that. And so this works out to 1/2 times 2. This is just 2x plus 5 to the negative 1/2. Or 1 over the square root of 2x plus 5. Same thing there. Now you're really forced to do this. In that case, you were forced to as well. But if you had something like this, find the slope of the line tangent to, slope of the tangent line, that's the derivative, f of x equals sine squared of x. The moment you see this sine squared of x, the absolute instant I see this, I rewrite this. It takes a little more writing, but it reminds me of what this actually means. It means find the sine of x and then square it. And so if we take the derivative, my outer function, right, sine of x squared, there's two things happening here. My outer function is that I'm squaring it. It's what happens last. My inner function is the sine of x. So what I will have here is the derivative of the outer function, f prime of x equals 2x, right? This is g prime of h of x. And so I need to plug in sine of x, 2 times sine of x. But I can't forget what the chain rule says is times h prime of x. So times the cosine of x. And so what we have here is 2 sine of x cosine of x. And so if I did here f prime of 3 pi over 4, this is 2 times root 2 over 2 times root 2 over 2 equals 2 times root 4 over 4 equals 2 times 1/2 equals 1 would be the slope of that tangent line. All right, last example here, putting it all together. We've seen the power rule, the product rule, and the chain rule. You can combine these. So if we had 5x times x plus 3, the first thing I would do would be to do the power rule. Sorry, not the power rule, the product rule. And so this would be f prime, right, the derivative of 5x, the derivative of the first part, which is just 5, times, I'm just going to leave this as x plus 3 to the 1/2, nothing changed there, plus 5x, that's f. Now, I'm going to do an intermediate step here. I'm going to say the derivative with respect to x of x plus 3 to the 1/2. So I just leave that undone. So this is just the product rule. And now I will do the chain rule to figure out that second part, the second step of this derivative. So everything else can just come down. We'd have 5 times x plus 3 to the 1/2 plus 5x times outer function x to the 1/2. So this is 1/2 x to the negative 1/2. See how I just leave it blank? Now I put on the inside there x plus 3 times, well, in this case, the derivative of x plus 3 is just 1, so it doesn't end up making too big of a difference here. And so what we have here is 5 times x plus 3 to the 1/2 plus 5 over 2, 5 times 1/2, x to the x plus 3 to the negative 1/2. And there's a bunch of simplification that you could do on there, but we don't need